So I think we can start. Welcome to week 20. It's the last week of our classes. Get started in OpenSys with STKO. Let me share my screen. Okay, so as I said, today we talk about equivalent frame modeling of masonry structure. I prepared two examples of a Trilite for you and one of a wall. There's different approaches that can be used to operate equivalent frame modeling of masonry. First, let's say they can be divided in two main ways if you want to use beam elements and so do a frame structure. One is to have a distributed approach and one is to have a lumped approach. We already discussed this for RC structures in detail. Let's say the idea is the same. Here we have the example with the distributed approach. Axial and bending stiffness are distributed along the length of the element, and the same goes for shear. In this case, in order to include shear, we had to add something called an aggregator. I think we already talked about this. But let's start from scratch. So we have a Trilite geometry. There's two different ways that the pier and the beam or spandrel can be connected into this kind of example. The two examples that I have show you the two different options. So one of the options is to create an interaction in between your elements. So just taking a step back, I'm sure you guys know, but the idea of equivalent frame modeling is the one to simplify a massive structure made of masonry by identifying specific pier, spandrels, and rigid joints elements in a facade. So let's say this is not a facade, but whatever you have a Masonry wall, you may have this kind of distribution and differentiation of the elements. This is because, just very simplistically saying, because damage has been observed to happen mostly in piers and spandrel in these kind of structures. And so the connections in between these elements can be assumed rigid. To do that in STKO, you can create, I would say two, just because you can create one, but to be honest, it's better to create two because I don't know how in a larger structure, how this would be organized. So let's say you create an interaction for each of the rigid connection that you want to create, defining a master, a constrained node and a retained node. And to this, you apply a rigid link. So this is one way to do this. I'm going to show you just the other one to be fast, that it's our second example. Another way to do this is to apply a very rigid beam element to the element that connects the two elements. So we created an elastic section, which is really small. Its geometry does not matter. And we applied a very, very high stiffness to the elastic section in order to mimic the presence of a rigid link. So this can also be another approach. And it can be useful if you know exactly what's the rigidity that you want to give to that link. So if you want to apply a specific stiffness to that link. So going back to my first example, given that we have a distributed approach here, we defined an inertial material for the concrete. In this case, my model is not anymore in Newton millimeter, but it's in kilonewton meters. So just for you to know. And we define, let me push it a bit further. This kind of behavior in compression, which is quite, it does not have the same smoothness as in a concrete. And this is not very fragile, it's not very brittle, but this kind of behavior in tension. And then going forward, not talking about for a second about the shear, we define fiber sections for both the pier and the beam. And we include them in an integration scheme with 5 integration points for the pier and 2 integration points for the beam, because the beam element is quite small and we don't need so many integration points along it. And to both, we apply first beam column element. So this kind of setup can be just fixed at the base. We fix the model in the outer plane direction. This is a suggestion that I give you every time you're trying to do a 2D model in OpenSys and STKO, especially if you're doing 3D frame structure and not a shell. I would suggest that you anyway use 3D elements and that you anyway work on the X zeta plane instead of the XY plane, which is, I don't know if you guys ever tried, but if you try to use the 2D elements, you have to work on the XY plane in STKO. Otherwise, nothing will work in the other planes. But anyway, I would suggest you to use the 3D elements and to work in the X zeta plane and to fix the movement of your elements in the out of plane direction. We just applied a vertical load to the two elements in the sides and an horizontal force to operate a pushover with a displacement control, moving the structure of 35 centimeters. So like this, you have no account for shear behavior. So it's like your structure can just, these kind of elements only mimic the axial and the bending behavior of a masonry wall. But that's not at all, let's say, realistic. So what we can do is we can add shear characteristic with the use of one of, this is just an option. You can use either pinching 4, hysteretic material, whatever it is that you want to mimic your shear behavior. I'm just going to show you my monotonic response. Let's put it a bit more. Okay, so this is the shear that I want to mimic for the masonry. And I didn't use any hardening ratio for this plateau, just a very, very small one. Otherwise, I had instabilities for my structure. This, in this case, even if it's called MY plus, it's actually my shear force. And in my x-axis, I have not shear drift, but given that I have a distributed approach, I have shear deformation. So whenever you're doing something with a distributed approach, remember that in your uniaxial material that you're using, whatever it's a pinching 4, an hysteretic, or an modified Ibarra-Venira-Krawinkler, whatever it is that you're using, you need to remember that what you're trying to include in your beam element, it's a behavior that is distributed along the length. So your curve has to be in force against deformation and not force against for example, shear drift. So in this case, I ran this model twice. I can show you the compared response as I input into the monitor the response without the shear, and you will see plotted on top the response with the shear. If the monitor will start. So as you can see, as I account for the shear, my total shear capacity decreases a little bit. Here in this case, I made a mistake. You guys can fix it. In the monitor, I could have just put the scale factor for the reaction force at -1, and I could have had my pushover curve plotted on the right side of the graph. Here in this case, let's imagine it to be plotted upside down. As you can see, there is something breaking here, but my structure keeps on going forward and forward, and maybe it could go even further. I did not check, to be honest, what happens going forward. But if we see my result, let's open a new file. Yeah, so if you see my result, you can see that what is happening is that the spandrel, the connection of spandrel to the pier is breaking. And what I would have liked to show you was the result in terms of stress on the fiber section. So what happened is that, as you can see, oh, wait, guys, I have a response in terms of stress. Okay, then it means that we fixed it. I don't know. Anyway, so as you can see, there's a very high stress at the bottom, and there's also high stress here in the faces connecting the spandrel with the piers. So most probably I would have seen, if I had not a beam element, but how can I say, shell element, I would have seen cracking, diagonal cracking here and cracking in the spandrel. So what we did, because we had a bug in the other computer, I don't know why we don't have it here, that I could not see the fiber plot. I had an alternative to this example, that instead of using the normal aggregator and beam section property, we could have used something called BM with shear hinge property, which is an element that's been developed in STKO to apply the shear behavior. Instead of putting it inside of an aggregator, you put it inside of this beam with shear hinge property, which is actually creating two elements based on the one that you defined. So you reference your section, your integration scheme that references your section, and you reference your uniaxial shear behavior, and you apply a penalty stiffness value to enforce, let's say, the continuity between the axial bending and shear degrees of freedom. And what do you do in order to use this? You can use the exact same shear law that you did before, but you have to divide your elastic stiffness, shear stiffness by the length of the element, and also divide all the things that you had in terms of strain by the length of the element too, because in this case you're dividing you're distributing the shear stiffness in a different way along the element. And what you need to add is also another element material, which is called beer with shear hinge, that references the element as before. If we make this analysis run and we compare it with the previous one, we can see that we have almost the same behavior, but there's, let's say, a double, how can I call this, step in the curve. And this is because I have another point in which my model can break. I will show you the result. I didn't load it yet. Oh, but it's still running. Let's wait for it to finish. Exactly, now it's finished. Let's load it again. Sometimes this happens that when your model is still running, you cannot really load the database. What I suggest you to do is to stop the analysis by clicking inside of the OpenSys console and load it while the analysis is not running. So once we have our second option, here you can see how, let's give me a constant size. Yep. I have not just one place where my structure can break, but I have two. So let's make this fiber smaller. Yes. And you can see that my beam with shear element created an hinge and lumped the shear behavior in the center of the structure. And this is more realistic for masonry, because if you think about it, what is happening in masonry is happening mostly, it's starting maybe diagonally on the corners, but it's working on also in the center of the element. And it's not like RC structure that you can assume that mostly shear failure will happen in the joints. So as you can see, even here, there's a bit of sliding of the two elements. So these are two different approaches that you can use to model with a three frame model and distributed plasticity in terms of shear behavior. If we want instead to use a lumped approach, which in this case is just lumped at the extremities of the element and not at the center, you can, as I said, this was just about the rigid link. You could have used either the rigid link as an interaction or the rigid link as a section property in either approaches. So it really does not matter which one is it that you are using. In this case, we define the Masonry property along the element as elastic. We define an elastic section, and we define an integration scheme for the elastic section. Then we can define pinching properties. These are the exact same property that you saw in the in the Ibarra Medina Kravinkler. I just put them here to show you that you can use indifferently both shear behavior. It's just the same. There's no difference. And then in this case, we need to model the axial and bending behavior in nonlinear terms, also to lump it at the extremities of the element. So to do this, instead of having, in this case, a shear deformation, we had a shear drift for the shear and a moment rotation for the moment, for the axial and bending behavior. Then we define a zero-length material and we assign these properties in the right direction. So I want my masonry to behave elastic in the X and Y direction, but then in the direction that I'm applying my vertical load, I want the shear to come to be accounted for. And the same, I want also compressive and bending in the fifth direction. So what I need to use here, instead of beam section property is simple, I use the pure integration scheme for the center of the element, and instead I use a zero-length material for the extremities. This could also have been done with a finite length approach to plasticity. So instead of having a zero-length element, I could have had a fiber section that I just used in the extremities of the beam, and this fiber section would have had the same exact characteristics that I used for the distributed approach, but then it would have been on a specific plastic length that I could have defined in an hinge beam integration scheme. So instead of using the beam section property here, we could have picked the hinge and then here selected the nonlinear materials, nonlinear fiber sections for the extremities and the elastic section for the center, and applied a plastic length, a length of the plastic hinge. And the same you do for the beam, just for you to notice, remember, just in terms of difference, like here, this is the maximum shear that I had applied to the beam, and this is the maximum shear that I applied to the pier. So my pier is way more resistant than my beam. And the same, so I have a hinge beam for the shear and a hinge beam for the pier and one for the beam. They should have the same name. Let's give it the same name. Beam, hinged beam. Okay, and the same as I did for the beam with shear hinges. In this case, I use the hinge beam and a zero-length element. I have to add an extra element in respect to what I had before. And I apply this to my structure. Same goes here. One thing that I added here was a self-weight that I didn't put in the other model. I should have actually, because it made much more sense to have both self-weight. Maybe we can try at the end and see if we can compare the result, because here I also put the right number here on the scale factor. And you can see that the behavior is much different. I can see exactly when my structure fails. And most probably is because of the presence of the self-weight too. And I also made a much longer time series. Probably it's not needed to do so, but you will see that we can capture a different behavior. Here I'm plotting the base shear in the X direction and the top displacement. So I can see much better how the structure is failing, and you will see that we have an actual drop at some point for our lumped results. It's a bit slow. I should have done a probably smaller time series. Yeah, let's see how long I put it. I exaggerated, I'm sure. Nope. Did I just erase my analysis? Yeah, oops, how did I do that? Here it is, 7,000, whoa, okay. Yeah, it was way too long to reach 35. It's way too long. Let's do it shorter, shall we? Because we don't need this long. Let's do 2000 and push to 35. The other model. See what happens. Yeah. We like it much better. So be able to load the new results. In this case, we have, yeah, exactly, this is the drop that I was expecting. Let's load the new results. Of course, we always have a residual capacity because our uniaxial material have a residual capacity. Wait. Yeah. There you go. Okay, as you can see here, it's breaking on this side specifically. And this was not so evident in the other case, as we did not have a lumped approach. So our, let's say, stress was distributed over the element, and we could not see exactly where the structure was breaking on the side on one side, because of course, this nonlinearity was not lumped in one point. And then I have one last example for you guys. I'm sure we are going to have some discussion on these things. I wanted to make, I had this wall. I wanted to show you how you can simplify this kind of wall in an equivalent frame method. So model with equivalent frame method. So you guys have piers, spandrels. In this case, even if there's a, you can create like a link here to, if you have a rigid diaphragm, but your spandrel can be as high as this double height, even if your I don't know how to call it, your diaphragm, let's say the floor is here. Yeah, exactly. But then you can create elements this height because of course they collaborate. If it's masonry wall, and then you have rigid links. So to simplify this kind of structure, I created this model here. And I use the approach of the rigid links. There's a lot in the literature of how high this pier should be. So most probably this is not the right height. You could account for a higher height or a lower height, depending on a lot of parameters. So just in this is most simple approach that you can get. What you do is that you define, again, in this case, I also had used the distributed approach with the same parameters as before. I defined like the fiber section and the aggregator with the shear behavior inside, and the fiber section and the aggregator for the beams, and the rigid link element for this applied for self-weight. And just the only thing that is a bit different from the others is the definition of a rigid diaphragm in 2D, which is something that we never talked about, how to do it. What's a rigid diaphragm in 2D? In the end, it's just constraining all the nodes of one floor to move as one as the other. So to move all the same in the direction of the pushover. So what you do is that you define an interaction that has one constraint node, and all the other in the same floor are retained, and the same for the other. This also could have been only one single interaction. And you apply then an equal DOF saying that they all have to move the same in the X direction. That's it. There's not much more to discuss. So this is what can be a simple simplification, let's say, of a masonry wall that you do manually instead of STK and OpenSys. And you can also run a pushover on this kind of structure. It was telling me at the beginning that, where's my monitor, guys? Yeah. I also made here a comparison between without the shear, so the dotted curve, and with the shear. As you can see, my response is much lower. At the beginning, it was telling me, I don't know if I will be able to see it anymore. Yeah. that there's too much constraint. So this is just a warning. You can decide to adapt your model to try not to have your warning. The warning is because I apply the outer plane to the whole wall fixed, and then there's also the base element, the base nodes that are fixed, and so it's telling me, you know, you applied too many fixed, and I cannot put them all. So just for you to remember, if we use the penalty method, you don't have this problem of the over constraint. You just go forward with the analysis, and nothing, it does not really matter. There's not really much that I can tell you about. This kind of analysis is quite easy. It's not really so complicated, considering that we did 3D analysis on frame structure, large pushovers, nonlinear time history. So the analysis is not complicated. The most complicated part is to understand how to simplify the geometry, especially if your structure is not regular. And so if the equivalent frame method approach is feasible for your structure. And second of all, how to calibrate your material properties. And this is something that you can use concrete material, uniaxial material, hysteretic material pinching for how you want to your masonry to behave. And just for you to remember, I repeat again what I said at the beginning, because we don't have a slide for it today, and so you will not have like a record of this. But if you're doing a distributed approach, your shear law has to be in terms of shear deformation. Instead, if you were doing a lumped approach, your shear law has to be in terms of shear drift. So you don't have a strain anymore, but you have a drift. And the same for your moment. Your axial and bending law has to be a moment rotation if you're doing a lumped approach. Of course, you don't need to define another law, because I mean, in this case, you know, this is a stress-strain relationship. And that's it. I'm sure you guys have questions. I already have one in the chat. Is it possible to account for the outer plane behavior failure of the Masonry wall in this type of model? So the one that I showed you was fixed in the outer plane direction, but you can make an attempt. We don't do much on equivalent frame modeling of these kind of structures, but you know that you can. And of course, we have examples. I don't know if we have one online already, or I can find it for you guys, of a micro model of an outer plane wall. I think I showed you already. And you can do it with macro elements, with micro modeling, so with macro elements. So just by using shell elements, or if you want specific elements, both for brick and mortar. And of course, this is the easiest way to do it with the shell element, because it's less time consuming to model. Let me find you the video that I was talking about. No, maybe I have it in a presentation. Yes, here it is. Share my screen. So you can do something very, very high-end and modeling all the bricks and all the masonry joints in this case. Or you can just use full shell elements and homogenize the properties of your masonry and use a layer shell with the fibers, so you can see the evolution of damage. And you will probably obtain a behavior like this. And you can do this on entire facades, not just one single element, of course. Yeah, of course. I mean, outer plane verification are either, I mean, to my knowledge, they're either done through like abacus, like you verify the strength of the single elements of your structure by a specific mechanisms, one-way bending, two-way bending, etc. But it's not like you're making a facade model in the equivalent frame method and trying to push it out of plane. Or they're done specifically with these kind of models more refined. But maybe you do. So I don't have experience with these calculations of autoplane using the equivalent frame method. Maybe you guys know that it's done and it's functioning. Somebody wants speaking? No. No. Okay. I don't know if you guys have any questions, any other questions. Go for it, Larissa. I know you have questions. I hope I can answer them.
Well, I'm revising my the models I did like 2 months ago on these.
Wait 1 sec. Maria Victoria was trying to talk. Please,
okay.
Does your microphone work? Yeah.
Yeah, I don't know if it's working now. Can you hear me?
It is.
Okay, yeah. Hi, Francesca. I'm quite surprised because I'm the one that opened, I think, one week or 2 weeks ago, the topic on the forum about how to model the masonries with the equivalent frame method. So actually, everything that you said today was for me was very interesting. I've been studying these weeks the approaches that you suggested, and the thing is that I'm trying to because I don't know if it's possible. I'm trying to see or to check if it's possible to analyze the plastic hinges. I mean, I want to know if the plastic hinges are overpassed. I don't know how to express that.
You want to see if there is failure in the plastic hinges?
Yeah. So I don't know if that's possible, because in the I mean, I want to see how the plastic hinges are working, and to do so, I'm not sure how to do that. I mean, I want to know if in which range the plastic hinge is behaving. I don't know if I explain myself.
Is it in terms of stress? You want to see like what's happening in the plastic hinge?
Yeah.
Like, because in theory, if you define a nonlinear material for your plastic hinge and the capacity of that hinge is reached, the model breaks in that point, no?
Mm-hmm.
I don't know. Could you see that in your application? Like, could you see drops in your capacity when?
If I follow the distributed approach, I can't, because in the capacity.
No, this is not. You don't have a plastic hinge in that case. You're just.
Yeah, but in the other, by following the Lampet approach, I haven't checked that. Maybe.
Did you do like finite length or zero length?
Finite length.
Finite length. So with the finite length approach, you can go inside of your stress results in terms of fiber stress, and you can plot, for example, the stress of one of the fibers in your hinge against time. And if you're doing either a cyclic analysis or a monotonic, you will see if that fiber is actually just behaving linearly or if something is failing there. You just a single fiber, extracting the results from there. So if you want to see that, I think this is the way to check. Like, you can see the level of stress that it's accumulating in that hinge, and or the level of like, you can integrate it. You can see, like, in that case, depends on what kind of result you want to check, but still. And then you can see the behavior if it's a monotonic. Are you doing a pushover or are you doing a cyclic?
Pushover. For the moment, pushover. Yeah. For the moment, pushover.
So I would suggest you go inside of each fiber. I cannot show you because I didn't do a finite length, but if, for example, I open the one, the distributed. Let me share. So, I mean, this is not distributed, but this is not lumped. But if I'm going here and I want to see, yeah, for example, I go here. I plot against time my stress here. So as you can see, in this place, there was no cracking, nothing happened. Like my fiber is still behaving linearly, because most probably I did not reach a level of stress that is, overcomes the behavior of the not the uniaxial behavior that I defined. So if it's not elastic, that's the way you can check. If it's elastic, this is always gonna do this forever.
Okay. Perfect.
Probably
Thank you.
will be different for I'm not sure, but it could be different for these fibers, given that. Exactly. In this case, I gave a much lower shear to my spandrel. So this is what happened to the spandrel. You can see that the behavior is degrading greatly.
Okay. Perfect. Thank you.
I've seen Matthias' reference, and yes, there is this macro element developed in OpenSeas for out of plane, but I don't think we have it in SDKO yet. I'm sure Vanin is the person that developed this. We were in contact with him, and I don't know if we have this in SDKO. We should check. This is the link that Matthias sent us. Do you know how's the element called specifically? But I think like you can use it in OpenSeas, but I'm not sure that we have it in SKO. I have to check with Massimo. I will ask him and probably post something on the forum about it if you guys are interested. Macro element 3D, let's check. No, I don't think we have it. We've been discussing with him to integrate it. This I know, but it's on our to-do list. Let me ask Massimo, but I think my response is correct. Is there, for example, no, because last time I remember that I told someone that someone that was asking me how to model rigid diaphragm connection and to give them not a completely rigid connection, but let's say a discrete connection or dumped connection, like how to model the diaphragm in reference to the walls and to model how the connection was strong or less strong. And I said that the possibility was there to use the embedded element that Massimo developed, but it was actually a desire because now it's only being implemented with face elements and not with beam elements. So if you want to do the things that I said last week, so using the embedded element to model the rigid connection between diaphragms and wall, you will need to use either shells or you will need to wait for Massimo to develop the, the embedded element also for beams. So we will see. I will ask him about the integration. In the meantime, if Larissa wants to start again with her questions.
No, the thing is, well, I did this like 2 months ago because I was trying to model a small house with the macro element and compare it to the EFM model in Diana. And the thing is, I have 2 questions. One is, when you define your aggregator, you define, so we add the shear behavior to our beam element, and you add the same one for the spandrel and the shear and the piers.
One.
It's the same one.
No, it was a different one. There were 2.
Okay, there were 2.
Uniaxial law. Even here, there's one for the pier, which has a level of shear that's 171 kilonewtons.
Yeah, and then
there is one which and it does not really go down because my pier is quite strong.
Strong, yes. Yeah, this is like a weak pier, weak spandrel, strong pier.
Yes, Not so weak though, huh? See, this spandrel is not so weak. It's still like quite plastic. I don't know how to define this. Like it's not so brittle, the softening in terms of shear.
Okay, but okay, so we have, okay, I was doing correctly because I defined one and then the other. Now I don't remember if I did if I actually put the deformation instead of a drift. I think I have an error there also. I had to check it and change it, but then my spandrel was like not moving at all. Like you know that you show like in the first one you did the, sorry?
You mean that they were not sliding?
Exactly.
Did you fix it?
Now I don't remember like what I remember, like the curve I got was really good, matching with my element, the one I got from the EFM analysis from Diana. So, but the problem was that the formation was like not all correct. So I was like, maybe it's because I have only one spandrel and then everything is a rigid link on top of the spandrels, on top of the piers.
Mm-hmm.
So maybe this is why the spandrel is not moving. But this is the only problem. Like if I do it like only the facade, I get this sliding, let's say, between pier and spandrel. But if I want to do like a full box, the spandrel doesn't work. Like for me, it's not working because it has no deformation or anything.
But so I don't know. I would have to see the model again. I was actually searching it because I think you posted it on the.
No, because I think this one was like my last. After we discussed everything in the forum, I think this was my last. I will have to review it all.
I think it does not really matter. I mean, maybe it depends on the deformation scale that you put in your visualization, and I don't know if the beam has to move. If you see, let's see the result of the other one that I did, like the last one, which is the whole facade. Let's see if this makes more sense compared to what you were actually visualizing. I actually stopped this at some point, but still. Did you put a rigid diaphragm connection? No.
Yes, I have a rigid diaphragm.
Was this happening, something like this or not?
Yeah, but no, see, my rigid links are not moving.
Your rigid links are not moving.
Like, okay, yes, the thing is, for me, it happens like what you see on top. This is what happening to me on my spandrel.
Was your pushover force both in this node and this node, or just in one spot?
Sorry, what?
Did you push only at one level?
On one, yes.
The top level.
Yes.
Okay.
I'm checking.
So in this case, I gave a specific flexibility to my rigid links. Flexibility. I gave a stiffness that it's finite. It's very high compared to the rest of the stiffness of the model, but it has, let's say, a number. It's a number, like 1 to the power plus 12. In this case here, they can bend and they can move because I gave them a finite strength. In fact, you see there's a difference into
yes. In my case, no, there is no. My case is like the one on top of yours.
But that's because probably you used the interaction and not the rigid element.
I have the interaction for the rigid diaphragm, but then I have the rigid link also.
Okay, and maybe you gave it a too strong.
Yeah, well, it's really strong. Yeah.
I don't know. I don't know if it's wrong or right, to be honest.
I was sorry, but I will have to like go again through the forum again, and I will post it there because I'm trying to remember why I choose all these values and I can. Okay. Sorry, I will have to review it, and I will post it maybe tomorrow.
You were not ready. You see?
I was not ready. I'm so sorry.
So we have another two. Okay, I asked Massimo about the macro level 3D, and yes, it's in our to-do list, but we don't have it right now. I'm sorry. And for Maria Victoria, how do I suggest to model solid walls? Okay, so yeah, I mean, you can either use brick elements like STD bricks. You can use Damascene, and you can also use our shell element if you want. So it depends on what you want to do. I can show you one model that we're doing if you guys are interested. I mean, that we already did. It's not something new, but it's gonna take a while. Do you want to do macro modeling or micro modeling, Maria Victoria? Both, okay. So there are a few, did you see that there are a few webinars on micro modeling and macro modeling also, not just the ones that you see here. Wait, no, I don't want this, hide, okay. So not just these ones, which are the ones that we always point to, but there are also these ones, which Larissa told us about last week, and we should remind everybody. Plastic damage model with Damascene is ready here, and micro modeling of Masonry Wall. And I think, no, there's just micro modeling, there's no macro modeling. No, micro and macro, this is both. I think the RC, the panel was made both micro and macro, yeah. This is the micro.
Yeah, at the end, he compares the two.
Exactly. And you can see there is like the same damage. Okay, Massimo? Okay. This was the macro. Yeah, it was smashed and the macro element. So you can go and check out the material for this. Files and content. Yep. No, this is day 1, day 2. Files and content. Let's see if they still work. We can use this time for that. Anybody else in the meantime have any questions? I'm checking a model I did with rigid links and like expanders and piers.
Just to further explain what I said, I just did this as a similar model, a similar basic frame as you did, Francesca, and yeah, the rigid links, the 90 degrees are remained. I mean, they are the angle between both interactions are not is not changing. It doesn't vary in, and I think that this is what you were talking about. I think
Larissa was worried that she was talking about the fact that her spandrels did not rotate.
You mean the spandrel?
Yes, okay. About the spandrel, not the rigid links.
Okay.
I think it also depends if you.
Yeah, I have a rigid link, but then I think if I do it with just the facade, let's say like the two piers and the spandrel rotates with the rigid link. But then if I make the box, I don't know if it's because the rigid link is really rigid. So no,
but you have to remember that if you make the box, you should not connect the end of the spandrel to your diaphragm. You should just connect links like the
Okay, so I connect my spandrel to the rigid link and the rest to the diaphragm.
Exactly.
Oh.
Because I mean, in the end, I actually don't know how it works in equivalent frame method, large like software. They do just that. How do they compute the rigid diaphragms? If they do, it depends if you want to account for the fact that that wall, if you, for example, have, as we had in our case, like an intermediate floor, and we have a very high spandrel in between those two floors, if you want to account for the fact that in the middle, that spandrel is fixed in its plane, or if it can do like this and that. I think it depends on how your diaphragm is connected to the wall. So if you want to account for that or no. But if you think about it, shear behavior is a bit different if you have, let's say, in plane movement of the middle element, or if the element is free to do like this. I don't know if Maria Victoria has another input on this. Did you do like larger structures or just walls and panels?
No, the same basic frame.
Okay.
So what you said is that the nodes. So you if you apply a rigid diaphragm constraint, you have to link, or you have to link the nodes that are in the rigid
joint,
and not the ones that correspond to the frames, right?
How you want to modulate, but yeah, if you want spandrel to be able to move the end of the spandrel to move one relative to the other, you have to not connect them.
Yeah, when you say it like
that
this,
makes sense.
It makes a lot of sense. I don't know why I didn't.
Okay. Next question, Emilio, do you know any tutorials where the modeling of masonry walls use solid elements appear? In STKO, masonry solid, we did just that one that I showed you. I think it was solid, no? The presentation I showed you. What do you think, guys? No, the video. Maybe it wasn't, but
no, not using solid. Using solid, there is no. To the best of my knowledge, there is no.
There is nothing.
Nothing.
Yeah.
Because all the micro modelings are for 2D.
Perfect. 2D. Yeah.
Yeah.
But we do have, I think, one on the one on embedding is with like concrete solid. I don't know if anybody of you watched it. So that one has some insights about how to model with solid elements. But anyway, there's not much, I don't think there's much difference. It's just about the element that you use. And also W20 3D can be used with 2D or 3D. Like does not change, the behavior does not change. It's by our triaxial behavior. Yeah, you have a very massive structure that you want to model, Emilio, so it would not make sense to simplify its thickness with a shell.
Sorry, Francesca, but simplifying it with the thickness of the shell, you cannot account for the pattern of the masonry, at least in my case.
Yeah, okay, but then that's micro solid modeling. It's not just solid.
Ah, well, yeah, like brick by brick. This is in that case, if you want them, I think for Shaz, I thought she was looking for micro modeling 3D. That there is no tutorial, but I think for macro model 3D there is. I think there is, because I did one, but I don't remember from where.
Because I don't think, but you are maybe more expert than me now after all this studying. Modeling the other plane failure of masonry structure.
No, sorry, there is no. You told me how to fix mine in the forum. This is what I knew. Sorry.
To model masonry walls of the contrahelixar building. Yeah, that's cool. So no, we don't have a tutorial for that. But if you do have specific questions about it, you can try to post one in the forum and we can answer. If you have a question about which is the right element to use, or how to define your constitutive behavior, just like post it on our forum and we'll try to help you. It's also a good idea to do a model example that we can post online so that people have this range of things to do. Yeah, so please do ask us on the forum and maybe we can do one for you also. Does anybody has any more question? I was trying to review MMC. Maria Victoria, we call you MMC here because that's your forum ID.
Yeah, it is. It is. It's me. Yeah. Yeah. For that, regarding what Emilio was talking about, as you know, I've worked with the soil structure interaction models, and for that I used the ND materials, but to model clays and then I used the standard brick element because I didn't want to work with the water and so and so. So maybe it could be a start. I mean, I don't know. I just suggested it previously in the chat, I think, because yeah. I'm also interested on trying to model the solid walls just to compare results with the equivalent frame method and
so also I would suggest to start from the webinar, which is about the embedding element, which is modeling a beam, I think, as a solid element, and that's a good start. You can use exactly the same material and the same element to model masonry. And yeah, I don't know, it depends on what is it that you want to do, if it's an entire structure or just a wall or a facade. We could do up some application and check what's happening. I'm sorry about the fact that you cannot use still the RC beam column joint, the RC beam column element that you wanted to use. I saw in the forum, but it will be ready soon for the other elements.
Yeah, because as you know, in masonries, the axial load it's quite important. So, for example, in other software, this computation of the shear strength is automatically updated within the analysis, and we were interested in trying to reproduce that instead of following different assumptions or hypotheses. We wanted to do that, but I think that as you said, it is still something that you are trying to.
Yeah.
Okay.
But it was not a good idea to put it right now for users to use, like in my opinion, but we did it and now we cannot take it back.
Yeah, I mean, I don't know how to do that. I mean, I know that I also send you some papers that I've been reading, and yeah, the authors assume the different criteria to take that effect into account, but it is an assumption. It's not the real behavior of the masonry. So yeah, it's something that we have to think about what to do.
Yeah, I will poke Massimo on finishing finishing the
and about the special purpose element, there was a bug, I think, and I also said that in the forum, because when I wanted to for example, you can select a material or a behavior for each of the cross section in which the element is divided, right? So when at the ends, I didn't want to add the torsion or the shear behavior, but in the middle span, I wanted to add the shear behavior. Well, if I didn't add if I didn't click in all of the you know, the boxes, there was a bug. Yeah, there was a bug, and
yeah, so that element still needs to be fixed. So when it is, we will post it on the forum, we'll post online, we'll let you know. Also because a lot of people are waiting for it, and Massimo is working with another engineer also on it, and yeah, it's long awaited. I wanted to show you this one thing about the files of today. We found a few bugs as we were doing these examples. So with the new version, you will need to add to your, so whenever you go, oops, here. So program files, TKO, external server, OpenSys, you know, you can find all the Python files that write your articles from STKO. I'm sure you guys already know. And so to be able to use these two models that I did today, 3 models that I did today, you will have to substitute this beam with shear hinge inside of element properties special purpose. There was a bug here. And then you also should go into utils and substitute this TKO input that I will provide. Then we're going to release a new version and just add these things inside. But if you want to use these models with the new version, so 2.0.4, you will need to substitute these 2 little files inside of your directories. Maybe I should make a text with instructions for you guys. So if you open it in a week and you forgot about it, you will know. So if you guys don't have any more questions, like we still have some time. So if you do, please to ask. Substitute the files. Okay.
I have my, but I don't know if I should show you now, or I posted something on the forum about the embedded element.
The embedded element?
Mm-hmm.
Did I give you permission to share?
Wait. Can you see it? Yes.
Hmm?
Okay. So let me see. So this is the model I have. So I have the solid here, and here I have the embedded element with my shell. Exactly, I have 2, one from one side and one for the other. Okay, on the other side. The thing is, when I run it, I don't know, the plot I get, it's here, this plot is the fiber of the shell and the volume together.
Did you synchronize the plots?
Yes, they are synchronized.
Why there is only one? No, because it's only one database. Okay. Yeah.
And so the thing is, I cannot make sense out of it. The curve I have, I like it actually. Is okay. Is this? Sorry.
Show me the curve. Sorry.
The curve is this one, and I like it. Yeah, I like it. Come on, it's like really nice when I compare to the others. But only this is the problem I have that is different from my experimental experimental test.
The linear branch.
Yeah, here I think it's still too stiff my material. but I don't like this.
Okay, let me try and so you don't like this.
Yeah, well,
No,
like,
no, I'm just, I understand why you don't like this. It's not making much sense.
right.
So, first of all, you have material damage in the volume. You put a range. Why? Like you're putting different things against one against the other.
Yeah, but because I don't have damage.
You don't have damage in your
And
fibers.
I asked for it.
You asked for it, but you don't have damage in your fibers.
Yeah.
You're using layer shell. Okay.
Yeah. Well, this is the other thing. I'm using the layer shell. I follow the instruction from the forum to make my sandwich that is symmetric, so shouldn't have any problem. Like, I don't know if it's the mortar, maybe the problem of my layers. I delete everything else if you want, because I have something else.
No, it's just wrong, this one.
Yeah. Is that?
So, but what about, so this is here. Can I check the file?
Yes, it's sticky.
STKO.
Ah, wait, sorry. I have to give it to you. It's on the other screen. So this is here. I don't know which one it is.
Do you have a HDF5 view? The view you don't have to open up the database? No.
No, sorry.
Just to see if it was empty or not. What does it do if I ask for this? It tell me error, color data sub empty mode fiber size. Haha. So you don't have damage, not because you don't have damage, but because there's a bug somewhere.
Oh.
So let me copy this. Will it give it to me on my computer? I don't know.
But
no, that's much to ask. Okay.
no, supposedly when you get remote control, you can do the copy paste thing.
It's okay.
You want a screenshot? I can send you a screenshot.
No, I already typed it. It was not very long. Okay, we will check into this error because I don't think it's what's supposed to do. But anyway, I'm sure you don't like your damage because you don't have damage.
Because this is what I told you before, that I want to see when
see the two things breaking in together.
Yeah, exactly.
So for sure, I wouldn't plot the strain, but maybe the stress, and it makes a bit more sense now.
Yeah.
Okay. Then.
Well, yeah, because at least they go together.
Take away. What element did you use? ICD, bar brick, acid shell copper. Because I asked Massimo about this. Bar brick. Okay. So first I would take away this and also here. What's the material here?
I have 3 materials for each layer. I have.
Yeah, but the plate rebar reference another material, no?
No, those are. Wait,
I think this window opened on your other.
Yeah, I'm trying to. My mouse is like doing weird things here.
Yeah, okay, but this anyway, you're using like uniaxial plugin. damage TC1D. So it's either damage TC1D or elastic, no?
Well, no, because the thing is, I have the isotropic material, the masonry for the volume, but then the shell is BTRM, the section layer shell, and there I have the direction X, direction Y of my mesh of inside my TRM, and the mortar. So I have a sandwich of mortar layers, mortar textiles and mortar, and this is the layer shell.
Okay.
This is why there is 8, 9, and 10.
Yeah, okay. It's clear to me. It does make sense. Let's see what Massimo said. But anyway, I wanted to show you just look pretty. There is steel also, no?
Yes.
So yeah, I think this is a problem with the results as damage, and then everything has to be renamed damage. And there's a conflict that happens whenever you use two different materials inside of the layer shells in terms of like you have steel and
no, but still this steel is this steel is not inside the layer shell.
okay.
No. The steel is just for the two beams that sandwich the wall where I put my loads and all this.
An error in the OpenSys console when you run that tells you damage. No,
I don't know.
you didn't check. Okay.
No, I didn't check.
Anyway, for example, here you have hot and hot. Okay, you have displacement. Let's put some more displacement and some more displacement. Now your computer is going to explode.
You can remove that if you want. I don't know. I normally put 0.
Makes sense to show. I would even put like this. But then now it's like my mastery is breaking, starting from your mastery is breaking starting from the edges. Instead, your reinforcement is breaking in the center, which does also make sense.
Yeah, but masonry should also start breaking from the center.
Massimo says to try and substitute in the layer shell.
Substitute what?
No, it's just no, because he thought that we had an elastic material instead of the layer shell. Instead, in here you have only damage TC1D here, no? One direction, other direction.
Yes. Because they are unidirectional.
I think it's the plate rebar too. It has that too. Anyway, for this visualization, yeah, I get it why you don't want to see. I'm sure the damage will visualize kind of the same things that is visualizing. Can we try just like you could try and do an attempt and see that instead of the plate rebar, you put your damage systems with the. I know it's not modeling your BTRM, okay? Just to see if you have no, but you cannot put that inside. What is he saying? Something stupid. Damage TC3D in a shell.
Is it possible? Because they have to be 1D. 1D.
No, not in the plate rebar, just directly here, I mean. Because damage TC3D is also biaxial. So
right, I will give you the. I have so many things on my. Yeah, that the monitor is in a weird position. Okay. There.
So like directly go here and see if you put this one, just to check that everywhere, because it's a damage TC 3D, just to check if you can see the result in terms of damage. Then,
Okay.
then if you see the result in terms of damage, you write to us on the forum and we try to fix it, okay? Because
Okay.
I think it's a problem with the plate rebar and the layer shell when you mix different materials. Massimo came, I think he's.
Hello.
I was saying that probably the problem is this one. So instead of using the, what is the layer shell?
Ci mettiamo il damage TC 3D che c'ha lei qua.
Wait, I have to give you the.
Sì, perché?
Oh, why are we speaking Italian?
I don't know.
Because you are used to speaking Italian between each other.
Okay, so what I was saying is that in the layer shell we can use instead of, so what did you use in the layer shell? You used
He used this plate rebar with this TC1D in one direction, the other direction, and then the mortar.
and the
Exactly.
mortar is what?
It's damage TC1D.
It's a sandwich. It's a sandwich of.
No, I mean, okay, but is there any 3D material there?
No, but
No.
this is for the shell, for the BTRM in the front. She cannot see the fiber damage on the shell.
Yeah, what I was saying is that we don't need to. Okay, let me see the results because I want to see how this error is generated, because I think it generates when you mixed two different kind of elements. So here you have the
Tipo adesso andiamo qua, we go here and we ask for damage. The damage is there,
section
but I don't see
damage.
anything, and it tells me this.
Says that it is different because you're mixing something there. So it is a shell.
It's as
So let me see select. Okay, so that one is the shell. And let me see all the elements inside the shell.
You have to drag it.
Sorry.
Okay, so
Mortar matrix.
mortar matrix.
It's all plate rebars.
And DRY and DRX.
It's like the rebar in one direction and the other direction.
Yeah, it's a textile in one direction and in the other.
So probably it's the plate rebar.
It's the plate rebar.
Sorry, 1 second. I don't know why it opens on the other monitor.
And here she has this damage, TC1D.
Yeah, probably it's the plate rebar. Because I remember that the plate rebar was giving me issues when you have the damage there.
But she can use an alternative to the plate rebar to do the directions.
Not so easily.
She can do. Why did you decide to use? She can use the damage TC3D to mimic the two direction, no? Because it's the actual tool.
Yeah, the only problem is that you want to see the damage there. So yeah, but there is a difference because when you use the plate rebar, you don't have any shear. So you just have a sigma in one direction, sigma in the other.
There's nothing.
And that is what I want.
Yeah, exactly. But when you use the continuum material, you have also a shear strength, an in-plane shear strength. Which anyway is going to be very small because the thickness of this one is very small. But,
yeah, it's very small.
The idea is that she wants to see the overlapping damage in between the masonry and a reinforcement.
As you can see there, you can see that it is messing up all the, yeah, it's due to the element, it's to the plate rebar. Because when the results come from the plate rebar, it comes from like 12 components without any integration point.
Yes.
There is nothing that you can do here. We have to change the source code because someone did a change a few time ago and didn't follow the rules of OpenSys. And so STKO is based on those rules and it cannot recognize the components of the damage. So yeah, I need to go and change the source code. And I think in the new version, they made also another mistake. Can you try? Yeah, I was looking at the source code just now. Can you try to plot section force and deformation on a shell? And let me.
Maybe she already tried.
Because
do you have the new version of OpenSys?
I don't think so. I don't have the 4, I have the 3.
Okay, no, because
No, but
we
of
recently,
OpenSeas.
yeah, we recently
no.
released a new version. Okay, so do not install it because we put new elements, but you have the new version.
Yeah,
Yeah, probably
here.
you will not be able to see the section forces and deformation in a shell.
Ok, non ci mettiamo come farlo.
Yeah.
Well, we will try by ourselves.
Yeah.
Okay.
Okay, so the damage.
We have to fix the source code, which we'll try to do it.
So the thing is, do I have an alternative to mesh to model this?
Without the shear, no.
Not without the shear. Let me do a very simple check, but I don't know if it is going to work. Okay, it's this
was
one.
The recorder to see if she was working successfully, but she doesn't.
No, it's not the problem with the recorder. I just want to try something. I don't know if it is in this version, but the orthotropic material.
Wait. I need to keep opening.
Not sure. I will try this one, and then probably I will give you an answer on the forum if we.
Yeah.
Now, okay. So here, for example, you have a damage TC 3D or Masonry isotropic. Okay. I want to try something. Materials and the isotropic material. If I use the same one and we use the same, do you remember what is the Young modulus of your material?
Yes, 90 gigapascals. The one of the reinforcement I want to do.
Okay, 19E, 9E.
Yeah.
What units are you using?
I'm using Newton. So.
Well, wait a second. Let me check all the properties here. I need to see the.
Wait.
Oh my God.
So maybe you can post this model and we can try and do it on the forum directly. We make an attempt.
It is not. It is 700.
No. Yeah, that's for the masonry, but for the material I want to model.
I just wanted to make a test.
Okay. Sorry, 700. Yes.
No, but it takes a long time to run.
Yeah, probably takes a long time.
Yeah, no, this one takes a lot of time to run. Yes.
Probably the orthotropic material can be used to lower the shear strength of the in-plane shear strength of a three-dimensional material. So you can use it as a plate rebar in that case, as a combination of two plate rebars.
Okay, so use the orthotropic material instead of the
plate rebar.
That is one solution. The other is that you have to wait for us to fix the
no, okay, no, I will try to do the orthotropic one, and I will post it in the forum if I have any problem.
It's just a problem of output, because actually the result is the same. Okay, it's just a visualization of the variable called damage.
Okay, thank you very much.
Grazie. She got yeah, it takes a long time though to fix the source code, so just for you to know, if anybody is interested in this. If you stop sharing, Larissa, we can close up our last week.
Sorry, there.
So Maria Victoria said, I don't have more questions, but let me know on the forum. Yeah, so I wait for you all on the forum to ask and post your models. And thank you guys for participating. It's been a long time that we'll be doing this, but we really hope it will be useful. If you find any, I would tell this for anybody who's actually going to use the series in the future. If you find any bugs, anything that doesn't work, any questions you have, please do post on the forum. We're always answering every day. And if you have inputs for future series that we should do, also do that on the forum. Like you have the series Get Started in OpenSeas, you can just post there and suggest something. I really would like to learn how to do this. And then if we get some more consensus, we can do it. You will probably receive a survey I know that you guys like followed me along the way, but a lot of other people did just through YouTube. So I hope we can receive a bit more feedback so that we can improve in the future, and also like make it in a way that more people are able to use SDKO and they can use it more. So thanks a lot.
Thank you very much, Francesca.
Thank you, Larissa, for participating always. And everybody else, even the ones who joined late, it was a pleasure. And I'll see you in the next series. There will be for sure.
Thank you. Thank you, Francesca.
Thank you, Valentina.
Thank you.